I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. At 69 seconds, the rocket ended itself. Not because a controller pressed a button, because an autonomous system made a decision faster than you can read this sentence and executed it with no way back. 5 satellites, gone. A payload from Taiwan's National Space Agency, gone. The rocket falls from 29 kilometers. The system performed exactly as designed. I'm Andreas Hamberger. This is the Hamberger Report, where I cover the orbital economy and what it means for AI governance on Earth. On 5th March 2026, Space One's Kairos 3 rocket lifted off from spaceport Kai in Japan. 69 seconds into flight, the autonomous flight safety system activated during first stage combustion and terminated the vehicle. This was the third consecutive Kairos failure. The first ended 5 seconds after launch in March 2024. The second failed at approximately 3 minutes in December 2024 due to thrust vector control issues. Third launch, third termination, 0 commercial orbital successes. Long the failure, Space One's vice president told reporters that no significant abnormalities had been found in flight or onboard equipment before the safety system triggered. And yet video evidence showed what appeared to be an energetic event in the plume, with fragments visible at around 70 seconds. Reuters reported a wobbly trajectory before termination. Who is right? The vice president, the video, the autonomous system that made the call? The unsettling answer is, nobody knows with certainty. The investigation is ongoing, and in the orbital economy, that ambiguity is not a temporary knowledge gap. It is the central governance problem of our era. The Kairos 3 flight safety system was not malfunctioning. That is the point. It had everything it needed: complete telemetry access to all vehicle systems, full decision authority to continue or terminate the flight, and direct execution capability through the termination mechanism. In the Space Mafia framework, that is the Lethal Trifecta, access, authority, and execution capability, all present, all active, all functioning, exactly as the engineers intended. In enterprise AI governance, the same trifecta describes why autonomous agents become high-consequence risks when verification is absent. An agent with access to sensitive data, authority to act on that data, and the capability to execute without human review is powerful. It is also capable of consequential errors at speeds that preclude intervention. Here is why the ambiguity at Kairos 3 matters more than a definitive answer would. If independent analysts reviewing the full telemetry record after the fact with unlimited time and no operational pressure cannot determine with confidence whether the termination was correct, then the flight safety system was asked to make a binary decision at millisecond speed with imperfect signal quality, where both error types produce catastrophic outcomes. Fire when it should not. A functioning rocket carrying 5 satellites is destroyed. Fail to fire when it should. A failing rocket continues on an unpredictable trajectory toward populated ground below. The system had no escalation path, no mechanism to communicate uncertainty, no way to flag borderline telemetry for human review, no ability to pause for 1 second and request confirmation. Long that is decision paradox. Not that the system was wrong, not even that it was right. The paradox is that at 69 seconds, with no verification layer separating acceptable operational variance from genuine failure, the safety mechanism and the threat vector became indistinguishable. The system executed anyway, and after the fact, with all available evidence, the humans still cannot unanimously agree on what the right call was. "24 hours after Kairos 3, 12,000 kilometers away. Rocket Lab completed its 83rd successful launch from Mahia. The same day the FCC closed its public comment period, on SpaceX's application to place 1 million orbital data center satellites into orbit. 3 events, 48 hours, 3 different answers to the same governance question. Japan's commercial orbital program has yet to achieve a single commercial orbital success across 3 launch attempts. Rocket Lab completed 4 launches in the first 10 weeks of 2026 from 2 continents, 6 days apart, and the European Space Agency booked Mahia for a navigation constellation mission. The contrast is not primarily technical. Both programs employ serious engineers. The governance architecture is different. Rocket Lab operates within New Zealand's Outer Space and High Altitude Activities Act framework, now maturing through the Ground-Based Space Infrastructure Act, with a compliance deadline of 29 July this year. Each launch requires documentation review and mission approval, building a regulatory cadence that compounds into operational reliability. The 1,000 launch licensing ceiling is sometimes characterized as a constraint on ambition. It functions in practice as a forcing mechanism for governance maturity. ESA did not book Mahia for convenience. Navigation constellations are long-duration strategic assets. When an allied space agency selects your launch infrastructure for a strategic constellation, the governance framework underpinning that choice has commercial value that accrues over decades. For New Zealand organizations and architects assessing orbital infrastructure dependencies, the practical implication is direct. Governance architecture is a supply chain risk criterion, not a secondary consideration. A provider operating within a mature regulatory framework carries materially lower supply chain risk than one where autonomous systems make irreversible decisions, and post-event investigations cannot reach consensus. Scale the Kairos 3 problem to 1 million autonomous systems. SpaceX's FCC application proposes orbital data center satellites at 500 to 2,000 kilometers altitude. Each one will require autonomous collision avoidance, autonomous station keeping, and autonomous safety decision-making. At those altitudes, the persistence gap applies. Above 600 kilometers, without active deorbit capability, debris remains in orbit for decades. Above 1,000 kilometers, for centuries. The public comment period closed on 6 March with substantial opposition from astronomers, environmental groups, and industry analysts, and with no governance framework on offer for the verification problem that Kairos 3 just illustrated at single rocket scale. Who builds the verification architecture for 1 million autonomous safety decisions made simultaneously, every orbital pass? Who decides the confidence threshold at which a satellite is permitted to act, and the threshold below which it must seek ground confirmation? These are not rhetorical questions. They are the design specifications for governance architecture that does not yet exist. The governance gap at 69 seconds destroys one rocket. The governance gap at 1 million nodes persists in orbit for centuries. The Kairos 3 investigation will eventually conclude. It will either confirm the system detected a genuine failure, or it will confirm the system terminated a functioning rocket, because it could not distinguish acceptable combustion variants from catastrophic failure onset. Either outcome is instructive. Both share the same root, a system with the Lethal Trifecta fully active, and no verification layer to introduce human judgment at the decision boundary. Autonomous systems making irreversible decisions under uncertainty is not a future scenario. It was a Tuesday morning in March 2026, 29 kilometers above Spaceport Kai. The question for every architect deploying autonomous agents and every board approving an agentic AI program is not whether your systems will face this moment. They already do. The question is whether you have built the verification architecture before the flight safety system fires, or whether you will be left reconstructing the reasoning from the debris. If you are tracking what the commercial space race means for your organization's AI governance, subscribe to the Hamberger Report for daily insights. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.